having seen the physical properties of metals, we come to the most interesting part, that is chemical properties. But this is the part that most of the students are scared of. But trust me, if learnt in a proper way, this part can be extremely easy. So what do we learn in chemical properties? We see the reaction of metals with oxygen, which is very prevalent in nature, with water and with acids. So we start with the reaction of metals with oxygen. In the earlier class also, you know the general formula, that is a metal reacting with oxygen forms metal oxides, and metal oxides are basic in nature. Similarly, non-metal oxides are acidic in nature. Now, if metal oxide is basic in nature, it will react with acid. So, generally, all metal oxides are basic in nature, while there are few which are both acidic and basic. That means they show both acidic and basic nature. And these kind of oxides are known as amphoteric oxides. So please note down that those metal oxides which show both acidic and basic nature are called amphoteric oxides. To give you an example, zinc oxide as well as aluminium oxide both are amphoteric in nature. Now here I will show you the amphoteric nature of these oxides. So generally, if I take any metal, for example sodium, and I react it with water, what I get is an oxide. Copper reacting with oxygen will give you copper oxide. You can also balance this equation easily. Similarly, aluminium also reacting with oxygen will form aluminium oxide. While these two we know for sure are basic in nature, this is said to be amphoteric in nature. The reason is simple. Look at the reason here. Sodium oxide, which I said is basic in nature, will react with acid and it will form a salt and water. It will form NaCl plus H2O. Now this will not react with any base. That is, if I try out this reaction, there is no reaction. The reason is simple. Two bases cannot react with each other. While what happens in case of amphoteric oxides is this. In case of amphoteric oxides, which I said have both acidic as well as basic nature, and the examples that I gave were ZnO and Al2O3. This is aluminium oxide. Let me take this for example. Al2O3 will react with HCl, which is acid. And in this reaction, we can see the basic nature of Al2O3 because it is reacting with an acid. And it will give salt, that is AlCl3, and water. And this is the balancing. Also, Al2O3, aluminium oxide, will react with NaOH, which is a base. And in this reaction, we can see the acidic nature of Al2O3 because it is reacting with a base. Again, it gives us a complex salt, that is NaAlO2, which is called sodium aluminate and water. So as you can see, amphoteric oxides show both basic and acidic nature, and thus you need to remember these points because again they become important from your exam point of view. In the next chemical property of metals, we see their reaction with water. So it's a two-step process in which metals first react with water to give metal oxide, which then reacts with more water to give metal hydroxide and H2 gas finally. So this hydrogen that is evolved is a characteristic of this kind of reaction, that is reaction of metals with water. Now, interesting thing to note down is that not all the metals react in the similar way, that is their reactivity differs. And that depends on how reactive they are. To give you an example, please look at here. Sodium will react with water to give sodium hydroxide and H2. Similarly, potassium also reacts with water to give potassium hydroxide and H2. Now, these are highly reactive metals, that is sodium and potassium. Since they are highly reactive as well as highly exothermic, large amount of energy is released, and it is so much that hydrogen that is released can also catch fire, and that is the reason that potassium and sodium are kept in kerosene so that they do not come in contact with the moisture from the atmosphere and catch fire. And so this also becomes a very important question for the board exams, that is, why is sodium or potassium kept in kerosene? And the answer is to prevent them from coming in contact with the atmospheric moisture so that the reaction does not take place, the reaction which is highly exothermic, and it does not catch fire. So many accidental fires can take place if this reaction undergoes. So as you saw, these two metals react in a very vigorous way. Next, if I see magnesium, it requires hot water to react with water, and it will give magnesium hydroxide plus H2. Similarly, calcium needs hot water to react with, and it also gives hydrogen. Now, the interesting thing that takes place in this category, these were highly reactive, these are mild. In this case, calcium and magnesium starts floating on the surface of water because this hydrogen gas that evolves sticks to its surface and makes it very light, and that is the reason it starts floating. Now here, from this point, we have got many questions from board exams. Firstly, why is sodium, or they can ask potassium, kept in kerosene? And I told you the answer. Second is, what happens when calcium or magnesium reacts with hot water? I'm sure you all must have got the answer for both these questions here. Next, let us move to the reaction of metals with dilute acid. Now, this is something that we've already done in the last chapter as well. Simply, when metal reacts with dilute acid, any acid, it will give a salt along with hydrogen gas. Taking an example, sodium reacts with H2SO4 to give Na2SO4, which is a salt, plus hydrogen. In fact, even if you take HCl in that case, you again get a salt and H2. But the exception is here, and this is the most important part, that HNO3, which is a strong acid, does not give hydrogen when reacted with metals. Most of the common metals do not react with HNO3 to give hydrogen, but some do. And these some, which are very important, are magnesium and manganese. So these will react with highly dilute HNO3 to give hydrogen. Now, what is the reason for this? Which is again an important question. So, the question is, why do metals not react with HNO3 to give hydrogen? And the answer is that HNO3 is a strong oxidizing agent. We've already discussed about oxidizing agent. So HNO3 is a strong oxidizing agent. So when it reacts with metal, the hydrogen that is formed gets oxidized to water. And that is the reason why with very, very dilute HNO3 only, few metals can give this reaction. While for most of them, this is the case. That is, their H2 that is evolved gets oxidized to H2O. I hope this is clear. Now, we got many questions from exam point of view here. So, please take a note of them.
If you like the video, please hit the like button, comment and share it with your friends. Also, don't forget to subscribe for all our future videos.